in learning target 11, we're just finding common logarithms and anti-logarithms. That's just vocabulary. A common log is a log with base 10. So on your calculator, when you see the log button right here on the calculator, that is log base 10. It's only log base 10, right? So if it says to find log of 424, you can just use that button because that means it's log base 10. So 2.63. If you're finding the anti-log, right, that's the inverse. And so that would be then the exponential form we've been talking about. So since a common log has base 10, we'd have 10 to that power. Okay? So if you're going to do that, then you would use 10 to 4.874 power. And conveniently, if you hit second log, there is 10 to that power. Any questions about how to do either of those things? Because that's learning target 11. Again, it shouldn't even count. Any questions? Okay. In learning target 12, there is such thing called the change of base formula. And this was way more useful for calculators got really smart. So back when I was in high school and college, before the calculators got updated, I didn't have a log base button in the calculator. I could just type a log in. So everything was based on common logs. So if I wanted to find the log base 12 of 18, for example, I would need to use log base 10 to find that. And the change of base formula says I can do that by taking log base 10 of 18 and dividing by log base 10 of 12. So log base 8 or base 10 of 18 divided by log base 10 of 12. We get 1.163. Today, you guys have updated calculators, they're way more fancy than mine were. So if you go to Math A, you can type in a log. Get the same thing. Totally up to you which one you think is faster. I always forget where the stupid log base button is because I never used it. So I always use change of base because it's easy for me to type in log 18 divided by log of 12. Math, and then scroll up. A. So yeah, so both of those exist. They give the same answer. Any questions about that? So on the second one, again, you can use whatever method you want. Again, I'm old school, and I think it's faster just to use the buttons on the main screen. So log base 10 of 15 divided by log base 10 of 8. I think it takes about the same time to type in either of them. So any questions about learning target 12? Because that's what that is. Okay. Well, then in learning target 13, we're actually learning something today besides use your calculator. So in learning target 13, we're solving equations and inequalities using common logs. So we've solved equations and inequalities so far in this unit a few times, right? We solved them when we had exponential functions on the first quiz. We had variables in the exponent, so we could rewrite all the numbers with the same base, and then we could just set all of those equal to each other and solve, right? No big deal. We've solved with logarithms already, but we actually had logs in the question, and then we use log properties. Either rewrite them as exponentials, or we set the two equal to each other, or something. We've solved things. Here we have alternate methods because, in this case, for the first one, you have 2.2 to the x minus 5 power equals 9.32. There's no way for me to write 2.2 to some power equals 9.32. So a 9, I just can't rewrite them. Like that's not going to happen, right? It's not feasible, okay? I also can't solve this with a variable in the exponent if I can't rewrite them. So I'm going to have to use logs and use log properties. Okay, so how you would solve this first one? You would take the log of both sides. So you would get log of 2.2 x minus 5 equals the log of 9.32. The log properties allow us to do something. So when we were solving logs before, if we had a value in front of the log, we rewrote it as the exponent at the end, right? Well, here I'm trying to get the x minus 5 out of the exponent, so I can use that same property to do the opposite. Right? I can take the x minus 5 and bring it out front using that same power property. So I can rewrite that as x minus 5 times the log of 2.2 equals the log of 9.32. That makes sense to everyone. Before we were going from like this step to the step before, we rewrote it as an exponent. Now we're just going backwards. And those properties allow us to get the variable out of the exponent. It is very, 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 very important to remember that a log of some number is just a number. Right? So people get caught up in these and get confused because they think that the log of something is some unknown magical something. I don't know. But it's just a number. It's just some decimal. I can type log of 2.2 in the calculator and I get a decimal. And I can type log of 9.32 in the calculator and get a decimal. All right? So they're just numbers. So if I have just numbers, I can just divide by log of 2.2 on each side, and then I have x minus 5 left by itself. Right? And I can actually get that decimal value. These are going to be full of gross decimals, so get used to it. X minus 5 equals 2.831, and it's a one-step equation. So you add 5 and get x equals 7.831. Any questions about that? That's not the only way you could have done that. You could have actually found the decimals up here in the step, and you could have distributed to x and 5 and solved it all that way too. That should involve more steps. You got the same answer though. So any questions on the first example? All right, on the second one then, we're approaching it the same way. I have 6 to the x minus 2 equals 4 to the x. I can't rewrite 6 or 4 to have the same base. It's not going to work. So I take the log of both sides. So I can bring the x minus 2 out in front of log 6 and the x out in front of log 4. And log 4 and log 6 are just decimals. So you have two options. You can find the decimals and you can distribute everything first. In this case, you can also just divide those values out because they're being multiplied and go from there. I'm going to take the shorter route. If you don't later, that's okay. You could have divided log 4 in multiple approaches to what we're doing here. So log 4 divided by log 6 is 0.7737. Now it's just an algebraic equation. I have 1x minus 2 equals 0.7737x, right? If I'm going to solve this equation, I have to get all the x's on one side and all the constants on the other. So even though there's ugly gross decimals, that's all we're doing. So again, different, you could subtract either x, doesn't matter. Since there's only one x on the right-hand side, I'm going to go ahead and subtract one x. So I don't have to move everything all over the place. So if negative 2 equals negative 0.2262 x, and so then we're dividing to solve for x. So 8.84. Questions about that? All right, you do the next example. I know it's an inequality, but you solve them the exact same way. So you do the next one, and I'll do the long, looks complicated one with you. Questions about how I got that answer? Okay. And on the last one. It looks super complicated, and it's not that bad, but it's lots of decimals and algebra and things. Okay? So, first thing, I can't have the fourth root in the middle of the problem. That's going to be an issue, right? So I need to rewrite that with exponents. So how am I going to rewrite the fourth root with exponents? Make it to the 1/4 power. Second, if I have all these exponents, it's going to get really confusing, so I'm going to go ahead and make all this exponent to one thing, so I don't have to worry about it. And there's a bunch of different ways this could diverge, and you can go different ways with this to solve it, and they'd all come out to be okay. So just the one way I'm showing you is not the only way this works. All right? So you have two approaches here. You distribute the 1/4, or you make it into one big fraction. In this scenario, it might be easier to make it into two fractions. All right, so you can either have x minus 1 all over 4, or you could have x over 4 minus 1 over 4. Either way, it'll work out. You choose. Any questions about what I've done so far? Again, this is not the only way we can do this. All right, I've got exponents I've got variables in the exponents. So I've got to get those out. So like we've been doing all the rest of these, we have to use logs to do that. Okay? So I have x minus 3 times the log of 3. Now, I'm going to have the log of all of this stuff together. Which is kind of confusing. So, think about your log properties. If you have the log of two things being multiplied, how can I split that up? How do I rewrite that? We did the opposite when we were solving equations before. If you have two values being multiplied in the log, how can we rewrite it with two logs? We can add them, right? We can sit there and write two separate logs that are being added. So x minus 3 times log 3. I'm going to have log of 2 plus, then I can move my exponents. So I split it into different logs. Right, you have to know those log properties. There's only 4 of them. Questions so far? All right. If you look at my notes from this point forward, then you're going to see lots of stuff still in log form because it's neater, and that makes sense to me. So if you look at my notes, you won't see all the stuff I'm going to do with you guys. I think it'll be easier if I do it this way, though, with you. But my notes have everything in log form. Because the more it's in log form, the less decimals to worry about and keep up with. All right? I can use properties to do some things with. In your all's case, just from experience with this, you guys aren't as familiar with the log properties, and I get that because we just learned them. And it's important to, again, remember that all these things that say log of something are just numbers. So the way I'm going to go about this problem with you guys is turn all the logs into decimals. Okay? That way we just have a bunch of numbers, and we don't have to worry about any properties or anything else. Does that make sense? If you're awesome at log properties, then you could do this without having to change everything first, and that's okay too. Again, multiple approaches to the same problem. So, log of 3 is 0.477. So I have x minus 3 times 0.477. If I have a number times a quantity, I have to distribute that, correct? So on the left-hand side, I'm going to have 0.477 x minus 1.431. Does that make sense? Then over on the right-hand side, log 2 is 0.301. Plus, we have this mess I'll deal with in a second. I have log 4, 0.602. All right. Does everyone understand what I just did, though? I just changed everything to logs, right? Distribute on the left-hand side because that made sense. I'm going to distribute over here in this highlighted box, too. But if we're going to do that, we need to put everything in decimal form. So x divided by 4 is really what number times x? 0.25. It's 1/4 x. So I have 0.25x minus 0.25. Now everything is in decimal form, and now I can distribute, and I won't lose track of things. So 0.25 times this value is 0.1505. Oh, we're going to. I'm just making sure everyone knows all these numbers came from. I lost anybody so far. So speak it. Again, this is not the only approach to this problem. So if you're doing it differently, you probably get the same answer and it'll be okay. All right, so this is just an algebra problem with a lot of ugly decimals, really. I have an x value here. I have an x value over here, right? I have 3 constant values. So I'm trying to solve for x. I need to get all the x's on the same side, all the constants on the other side, and solve. Everyone understand? That makes sense. So I'll leave this one up to you. Would you rather me subtract 0.477 or subtract 0.1505? Perfect. I keep writing at 1 point. Okay. If I do that, that means all the x's are going to be on the right-hand side. So that means I need to add the 1.431 to the other side. Does that make sense? Right, just an equation. So if I do that, that's not what I meant to hit. All right, 0.47. Oh my gosh. 0.477 minus, it's really 0.1505. I don't know why I continue to write this as 1.505. So I get 0.3265. Over here, I've got 0.301 minus 0.1505 plus 1.431, 1.5815. And then we're just dividing, right? Now I've rounded, and so I've rounded quite a bit instead of using what's in the calculator, so if we're off a little bit, I understand why. Get it. I rounded a lot. We have lots of decimals. Okay? Questions about that? I know it was a long question. It used log properties like the first 3 steps, but then the rest of it was just nitty-gritty algebra type stuff. Any questions you have at this very moment?